Let's start with the graph f of x is equal to ln of x plus 1. In order to find the area of the graph f of x is equal to ln of x plus 1, we need to take the integral from 0 to 20 of ln of x plus 1 dx. To do this, we use u dv and say u is equal to ln of x plus 1, dv is equal to dx. We can then find that du is equal to dx over x plus 1 and v is equal to x. So the integral from 0 to 20 of ln of x plus 1 dx is equal to x ln of x plus 1 minus the integral of x over x plus 1 dx. We then solve that in order to get x ln of x plus 1 minus the integral of 1 minus 1 over x plus 1 dx. Again, we get x ln of x plus 1 minus the integral of dx plus integral of dx over x plus 1. So the integral of from 0 to 20 of ln of x plus 1 dx is equal to x times ln of x plus 1 minus x plus ln of x plus 1 from 0 to 20. So the integral from 0 to 20 of ln of x plus 1 dx is equal to x plus 1 times the ln of x plus 1 minus x from 0 to 20, which is equal to 21 ln of 21 minus 20, which is equal to 43.935 units squared. Let's now rotate the function f of x is equal to ln of x plus 1 around the x-axis. In order to do this, we are going to use this method. This method uses the formula v is equal to pi times the integral from a to b of f of x squared dx. So we are going to use v is equal to pi times the integral from 0 to 20 of ln of x plus 1 squared dx. We put this in the calculator and come out with v is equal to 335.464 units cubed.
Hey, what's up?
Nothing much. What happened to Dennis?
I don't know. I haven't seen him in a while.
Well, let's look for him.
Okay. Look, on the mountain. There he is.
Who's that behind him?
Where?
Right behind him.
Whoa, special ops.
What are you doing?
You think it's gonna rain tonight?
Who cares? Shoot him.
I got a date.
With your mom?
Shut up.
God, just shoot.
I think you can take him. Yeah. That's that.
You want to shoot him now?
Yeah.
How long does it take the bullet to hit the special operations enemy? Given that distance is equal to 150 meters, acceleration is equal to negative 0.637 meters per second squared, v naught is equal to 854 meters per second, and s naught is equal to 0 meters. So first we do the integral of a of t dt, which is equal to negative 0.637 t plus c. So v of t is equal to negative 0.637 t plus 854 because we use c is equal to v naught, which is 854 meters per second. Then we take the integral of v of t dt, which is equal to negative 0.319 t squared plus 854t plus c. So S sub t is equal to negative 0.319 t squared plus 854t plus c. In this case, c is equal to s naught, which is equal to 0 meters. So S sub t is equal to negative 0.319 t squared plus 854t. Since the distance is equal to 150 meters, we set 150 equal to that previous equation. We then subtract 150 from both sides in order to get 0 is equal to negative 0.319 t squared plus 854t minus 150. We plug this into the calculator, graph it. We find 0, which comes out to t is equal to 0.176 seconds. How long will it take the special operations enemy to hit the ground, given that g is equal to negative 9.8 meters per second squared, v naught is equal to 3 meters per second, and s naught is equal to 5 meters? Using the diagonal velocity 3 meters per second, we can find the y component of this, which is dy dt. So sine of 45 is equal to y over 3, y is equal to 3 sine of 45, y is equal to 3 root 2 over 2. Using the formula, S sub t is equal to 1/2 gt squared plus vy naught t plus s naught, where vy naught is equal to dy dt. So 0 is equal to negative 9.8 over 2 t squared plus 3 root 2 over 2 t plus 5. So we plug this into the calculator and graph it and come out with t is equal to 1.250 seconds. What is the distance the special operations enemy travels before hitting the ground, given that t is equal to 1.250 seconds and v naught is equal to 3 meters per second? So, using the diagonal velocity 3 meters per second, we can find the x and y components, respectively dx dt and dy dt. In order to find the y component, we set sine of 45 equal to y over 3. So y is equal to 3 sine of 45 and y is equal to 3 root 2 over 2. In order to find the x component, we set cosine of 45 equal to x over 3. So x is equal to 3 cosine of 45, which means that x is equal to 3 root 2 over 2. Using the formula for arc length, integral from 0 to t of square root dx dt squared plus dy dt squared dt, we plug in time and the x and y components. So integral from 0 to 1.250 of the square root of 3 root 2 over 2 squared plus 3 root 2 over 2 squared dt. Distance comes out to 3.750 meters.
Got him in the butt.
That's weird.
So, Dennis is dead. Anyway, let's go play Halo.
Okay.
Hey, what's up?
Nothing much. What happened to Dennis?
I don't know. I haven't seen him in a while.
We'll look for him.
Okay.
That's bad.
Shut up, guys! Hey. I was
What was that?
Hey. What's up?
You gotta be like closer because you're so
I'm
quiet
sorry.
anyway.
Look.
Who's that behind him? Right behind him.